previous video we stopped at the point where we figured all the exposure values and how to make sure that all that stuff is calibrated. One thing that we didn't talk about, that's a whole different discussion, is calibrating all the colors, and that's a separate topic. The only thing to keep in mind that the color space of final textures is the same as the color space of input footage. So if somebody used Adobe RGB, then here we have Adobe RGB, regardless of what that color profile says there in Photoshop. If it's done in this RGB, then it's in this RGB, and so on. Some builds that we did would work directly in color space of the sensor, and that works as well. So in this case we skip that topic for now, because we can see that some of these blue colors are not quite blue. There's some magenta or cyan, it's hard to tell what these are, but that's a separate topic. As long as all intensities are correct, then all our materials would be correct. So now let's focus on building, treating this color chart as just a 2D material, and build the high resolution data, and fire up the shader and set all the settings, make sure that it renders in the same way as the source footage. So for that we have a useful script that's called resinfo that will go and analyze UV map, and it would tell us optimal texture resolution for the final build. Here it says it's slightly over 4K, so we'll just use 4K and that will work just fine. So now our parameters build, we'll make a few modifications. First of all, we will disable parameter that has to do with sharpness. So before all images are taken into account, we can apply sharpness in case if something was shot with high f values, so it's slightly more blurry than it should be. So to be more accurate, let's disable that. And another parameter that we'll disable, that we will, because we will only use a single camera, has to do with normal map correction. When we build this photometric normal, it's very it's quite often it would also capture all indirect and anisotropic effects. When dealing with 2D materials, we don't really need all those corrections. So for more accurate results, we actually, for 2D materials, want to disable this and transfer radius. And what that basically does is that it takes higher frequencies from photometrically built normal and lower frequencies from geometric normals that are built from either a structural light scan or photogrammetry or a laser scan. So that's geometric stuff, so we disable that. Another thing, here we have our cameras exported from Metashape. In this case, let's just create a copy and create a special file with just one single camera in it. Let's call it cameras_1 or front XML. So now we go back to our photogrammetry. One way to do it, the quick way, if you're good with text editors, we can just go and delete all the cameras that we don't need. So we'll just leave the one that's front facing and remove all other ones, and save it as cameras01, like so. If you're not that good with text editing, you can always just re-export it again from Metashape. For instance, in this case, one way to do it is just to delete all these other cameras and leave only the one what we need and re-export them. Or another solution is that you can disable them, and we can go and export these cameras, let's say cameras1A. Then we can go and look at that file, what has been exported, and we would see that all these other cameras would have enabled set to false except for this EOS 01X003. That's the one that facing where that chart is facing the camera. So either way, we'll use the one that we created by hand, so we know it should be 4K. Great. So we go to solve 4K, everything is set up there, and we go build. And right, because we say front but we called it 01. Okay, called it front. Done. Here 4K build, and now it will just read that just one, basically 24 shots that for that one single camera, and build all the data. Okay, that took 30 seconds. All the data should be there already. We can quickly inspect it to make sure that everything is like, yep. So the reason I'm doing average there, because if you zoom in, you could see that there's some noise there in this chip. So if we average it, okay, it's around 39. We can also notice that here that the white balance is not quite set correctly. So again, that's pretty easy to correct later on as a post-processing step. Ideally, you want to adjust it in your camera for specific set of filters and lens and light sources or specific rig, so that it's as close to gray as possible. But that's fine, we won't worry about that for now. So that seems good. We got our data, and then we have a useful script that would do generate and preview Blender file, where we can run the script, and we'll get our color chart in here that's already rendered. However, the values right now are not quite calibrated, so now we'll go ahead and using those images that we exported for reference, make sure that everything renders correctly here. To do that, first let's disable all these other lights. We can see that there's some world, and also keep in mind that what I'm showing here, the exact same set of steps applies to any other render. It could be tool bag, it could be like Redshift, Cinema 4D, Sketchfab, you name it, Arnold, Unity, Unreal, it doesn't really matter. It's just the general set of steps that's important, and not the specific package. So here let's just kill all our ambient lighting in so it's easy to see in EV render. Again, we can disable all that bloom and ambient occlusion and screen reflections. Another thing that we have set here is some exposure that we don't need, and gamma, set it back to 1, and don't apply any look modifiers, and don't apply any, actually I'm going to for the sake of a tutorial have very wrong values here so we can see what's going on. So let's copy this one light, so we will work with this one, so something moves around. We'll also disable all those other spheres, so obviously it's too bright and wrong. Let's just set it over here for now, and bring our reference photographs that we created. So split it vertically. I'm pressing N there. Again, you can look all that up for Blender, but as I said, it's not important whether it's Blender or something else. Let's go to where we saved those references and open. We'll use exposure corrected version of diffuse chart. So now one important thing here in Blender specifically is that under image it has this, or tool, where was that, view image, yeah, image view as render. And that's an important option because when it's viewed as render, it reads it as sRGB and then applies all this color management things that we have over here. So when we do want to have a fair comparison between what we see on the left that's rendered and the actual reference image, we need to make sure that thing is set. So now we go and disable this filmic curves, just use standard sRGB. We see their difference. We see that exposure affects the two. Let's set it to 0. That's the value by default. Gamma to 1, and that's it. So right now it's pretty much, if we turn it on and off, we won't see any change here. So this is basically a vanilla version of our image that now we can try and set up all other components. So in the shader, we do use specular PBR model. Let's save this file. In specular PBR model, as opposed to metallic one, we have separate control for diffuse and the specular, because very often, in many cases, you would have kind of, especially with vintage items like statues and so on, you would have greenish, bluish diffuse, and at the same time yellowish kind of golden specular, and it's not possible to create two completely almost complementary colors using metallic parametrization. So in this case we have diffuse, so it's basically in Blender specifically we use diffuse it's all principal BSDF, but the one diffuse where we disable all specular, and in the specular one we set metallic to 1, basically 100%. It means that the base color now and everything affects specular and there is no diffuse component. So now let's go and disable our specular. So what we'll see here is just the diffuse lighting, diffuse lit component, and that's our image on the right. So this is for now. That's wireframe, that's material preview, that's just solid color. But in material preview we can also here lock the shader so it doesn't jump over. If we move light around, we can see that something is changing there. So for that, so we'll see our light. Let's disable shadows so they don't throw us off. One thing though, as you can see, the light source is set as a sun, so basically it's a directional light source. Angle 5 degree, okay, fine. So the point right now here is that, as you can see, we move light around, but the intensity changes. So the trick is now to try to set that light direction that's similar to what we have in a photograph, and it's obvious that just using diffuse component we cannot do it. There's a way to import all these cameras and lights from the rig definition so it's exact, but I'll show you kind of eyeballing way of doing it. For that, let's just grab our specular version of that light, make sure that it's view as render, and here's quickly go back to our specular, and now let's try to move that light around until we get something that looks similar in terms of highlights to what we have on the right. Obviously it's too bright. We might have to adjust some primers here. and again you can see that it's doing it this way is a little bit can be a bit tricky, because we have some, as we change view direction, some things change there as well, so it's not as easy as it might look, but we try our best. Maybe something like that. And this is where it gets a bit something that can throw you off in these renders as well, is the fact that so roughly we can see that all the highlights are pretty much sort of close enough. Maybe we can move it a little bit here, but it might be view dependent, so for this case it's also useful to put some mirror ball in there, but let's say it's close enough. Now let's make sure that our light intensity for diffuse is correct. I know that the value of 3 is what it should be there, but we will check it anyway. So we switch to diffuse, and there you go. So basically values here, again, one way to do it is to basically just take a screenshot and bring it into Photoshop, and by adjusting the curve make sure that all the chips would disappear sort of at the same time, more or less, especially that 50% one, so we can see that we could probably add a bit more, but again, if we change the light source, that also would affect the intensity of that chip. So that would be our diffuse. The next, so yeah, light turns on and off. That was the C chart, and I just noticed that the specular one was not the exposure corrected one, and we did the exposure, so actually we need this one, EC chart spec. That would be brighter probably. Yeah, so that was our diffuse. This is now exposure corrected spec. We go to spec. Now let's adjust reflectance here. It should be around 0.3, something like that. So at least I know around 3. That's the correct value in terms like specific to Blender, and again we can save that. You can see that there's definitely, if we zoom in, the character of detail, that's 1:1, and that's also 1:1. We can see that the original images, they're a bit off because they were a little bit out of focus, but in terms of other things, that's where we can adjust things a little bit using gamma, looking at those darker parts, make sure they're in the same scale, and maybe increase roughness, and there you go. But now if we zoom back, it's not quite, it went off a bit. And again, as I said, the better way to do it is to get the exact camera position and the exact light direction from the camera's XML file, and we have scripts to do that. Right now I'm just showing kind of manual eyeballing way of doing it. One thing that can throw you off additionally is the fact that in Blender, when we zoom out, these images don't apply, it doesn't apply any MIP mapping. So as we go to progressively smaller images, it shows more detail than there actually is, because it basically, we see a lot of Alice in here. So if I want to compare images at this scale, I know it's, so that's 1:1, that's 1:2, that's 1:4. What we could do is to basically generate a smaller version of that image. So if you go to open this one, and let's do 25% bilinear, save it, and the score Q, basically quarter size. Go back to Blender, open this version, go to 1:1, and now we would be looking at something that's roughly more in the same range there that we had. And so we overall kind of set all the scale, can adjust all these roughness parameters a bit, and again, that's pretty much all should be consistent across materials there. After this, we'll look at another prop that would be a bit easier to deal with, but this is a general idea of how you get to these values. So this was just the specular. We go back to make sure that the diffuse component is still fine. In terms of intensity, okay, so that's all good. Now let's look at the composited images. EV chart. Was it this one? I see one comp, I don't see the other. I probably did not call it correctly. EC chart, probably that's the one. So if we add diffuse and specular back together, and this is roughly where it is. So we can kind of move around and see that the specular changes here. So this is EV. There are a few other things that can affect the look a little bit. Is basically the filter size that goes on top, and that would affect sharpness. It also kind of throw you off a little bit. Obviously view direction would throw you off a little bit, but as we are in EV, that's a real-time render, we can do the same stuff and switch it to cycles, and in this case it's all path traced, but a bit more correct. Another thing by default, again, also to get a more accurate result, some of these textures, make sure that everything uses some form of interpolation. As here you can see that it would just use closest neighbor for texture interpolation, and that's also not always good. But in general, that's the idea when it comes to this type of correction. Again, you could see that in light sources here we use value of 3. Roughness is a bit undershot, so we use 1.1, 1.2 by default. You can adjust the gamma on that texture a little bit. The reason for that is that while we target a GGX specular distribution. For some materials, in reality, it might be a mix of two different distributions, so it's not always 100% represented with a single one, but you can artistically adjust so that you can still get away with just a single specular lobe. And reflectance is usually around 0.3, 0.4 with those values that are calibrated. This is specifically talking about this shader setup in Blender. For other packages, it can be different, and we've seen like very different things there. But once you do it once, now you scan another prop, you punch it in, and it would look exactly the same or very, very close to it, given into account what I just said about different lobes and correcting slightly just for a single lobe. So that's pretty much it, and in the next part right after this, I'm going to take another prop and also kind of walk through and show a similar approach again in here, to show you how close you get there in terms of reference footage and a render.